192.168.0.0/16, and that will host approximately 65,000 IP addresses. Good. What next? You want to create a public subnet with 192.168.0.0/16. All right. So you create another
Yes.
subnet inside it with you choose another subnet with the following data block. That means here again you're consuming 65,000 IP addresses. Now you cannot create any more subnets because you have consumed everything out of the primary subnet. You're done with the subnets here, so you cannot create this guy. So in the larger network like this, you have to create smaller networks. What you have to do is pick up a smaller network from the primary CIDR block or the CIDR block of the VPC, which will be a subset of the VPC, which is 192.168.30.0/24. Now here you will have 251 IP addresses equal to 251 IP addresses. Now out of the 65,000 IP addresses, you have consumed only 251 IP addresses. Now again, you can create as many as you want. You know what I mean?
Yes, please.
Okay, you got it right.
Yes.
Okay. Okay. I'm waiting for few more participants. Just give it another minute and then we'll get started. But then we can use this time for any Q&A, any questions and answers. I think Manny, your friend, was also joining today, Mr. Joel.
Yes, it should be joining pretty soon.
We'll start off in another minute. Okay, let's get started. Before we start, I will start with a review of what we did yesterday. We learned about networks, how two devices talk to each other, what is a CIDR block, how do you calculate the number of um, IP addresses in a CIDR block, and then we use that knowledge to build a VPC, create subnets, create internet gateway, and then the importance of adding routes in the internet gateway. Then we created a Windows machine in the EC2 instance, made that as a web server, and we were able to access the web server from the public IP. And since we created a Windows server, we'll create a Linux server today. Creating a Linux server is no different. You'll get similar screens, but logging in, getting the password of that instance is a little bit different, not difficult, but a little bit different. So let me just quickly draw this. This is the kind of VPC that we created. This VPC that we created yesterday had two subnets, subnet 1 and subnet 2. The CIDR block of each one of them was also decided as 192.168.40.0/24 and 30.0/24. And then we created a Windows machine. We created a Windows instance in one of the subnets, and then we were able to access that from the internet. Yeah, let's also represent an internet gateway. So that is an internet gateway. Okay, that's an internet gateway. And we have the routes written inside it. Good. Today, what we will do is, instead of creating a Windows machine, we'll make a Linux server, make that as a web server 1, and try to access that from the internet, same thing. In addition to that, we'll also create a second web server, call it as web server 2, right? Again, access that from the internet. Then we will go ahead and create a load balancer. We'll go ahead and create a load balancer. That load balancer will again have a name which we should be accessing from the internet. And once the traffic comes and lands up on, let's draw this. Once the traffic comes and lands up via the internet to the load balancer through the internet gateway, look at the picture, it is coming through the internet gateway. So the traffic comes all the way from the internet to the internet gateway and then to the load balancer. The load balancer must route the traffic to one of these servers, right? So it either sends it to web server 1 or web server 2. Sorry, it either sends it to web server 1 or web server 2. And this should happen in round robin way, right? So load balancers work in round robin method. So that will be the objective of today. So we make a Linux server, log into that, make it a web server, try to access that from the internet. Make another web server in a different subnet. Keep in mind that both of these subnets are in different availability zones, right? And then we'll make a load balancer and put them behind, put these two web servers, server 1 and server 2, behind the load balancer, right? And then every time we try to access the load balancer, it should send it to one of those in a round robin way. Round robin means the first traffic goes to server 1, second traffic goes to server 2, third traffic goes to server 1, fourth traffic goes to server 2. So it's gonna do the round robin thing. right? Go to my EC2. You can pick up any Linux server. You can pick up SUSE Linux or Red Hat Linux launch instance. And then in my case, I have this habit of picking up Amazon Linux image. Why? Because it has everything. If I want to write a Python program or a Ruby program or a Perl, Java, I want Docker, I want PHP, I want MySQL, I want databases, it has everything. So I don't need to install again and again. Whereas in rest of them, you may have it or you may not have it. Look at this. This is a SUSE server. It doesn't have anything. It's just a plain vanilla build operating system. Nothing. So we will go ahead and create a Linux server. And we are creating an Amazon Linux image. AMI stands for Amazon Machine Images. These are all images, right? All right, so let's go and click on select. Now we'll be assigning 1 CPU and 1 GB RAM by selecting T2 micro, right? Do not select any one of these. Just select this one. Don't select the rest of them because you'll be charged for that. And for lab purposes and even for certification, for learning purposes, T2 micro is sufficient. Next, I want one machine in my VPC, right? That's my VPC. Oh, no, this is not my VPC. I think we were doing all our labs where in Ohio, right? Not in Ireland. So let's go switch back. Sorry. Okay, select that image, T2 micro. Right, this was our network. And then I will host one of them in network 1 and second one in second network. And I want to give it a public IP address. I'll say enable. And then rest of these values is something that I explained yesterday. I'll leave them the way it is. Next. Now, what's different here? When you're creating a Windows machine, the default size was 30 GB, but in Linux, 8 GB, right? You can go up to 30 GB. Look at this. Free tier eligible customers can go up to 30 GB of elastic block storage. EBS stands for elastic block storage. There are two kinds of storage primarily. One is a block storage and second one is an object storage. The differences between object storage and block storage is something that we'll look at when we are talking about storage explicitly, right? We also learned about the volume type. In our case, I can happily live with general purpose, and we looked at these options yesterday. And then I'll add a tag as name. This is web server 1, right? And maybe if you want to add some more items, you can add business unit. It belongs to the web app team. And then just say owner. Owner is Joe at myproducts.com. He's the owner. All right. Next. Now, one more thing that you might have noticed. Yesterday, we created a Windows machine, so it automatically opened up port number 3389. But this one is not Linux. So this one is not Windows. Because it's a Linux machine, it automatically picked up 22 because Linux listens on 22, right? And hence the port number is SSH. But our objective is to add or make it a web server as well, right? And you know what to do. Just click on add rule. In the drop-down menu, you select HTTP, and then you do this, right? But I will not do it now. If I do it now, then you will not know how to modify it later on. Let's say you forgot about it, or let's say the request comes later on after the instance is created. You should know how to modify it later on as well. So I will leave it for later lab practice, right? And finally, I'll click on review and launch. Look at these options. If you're happy with that, click on launch. And just like the Windows machine, you got this pop-up. It says create a public key and create a private key. Good. Now I can use an existing key pair. One key pair that you have can be used for multiple instances. This key pair is something that we created yesterday for logging into Windows machine. I can use the same key pair for multiple instances regardless of their operating system type. Let's make sure that you have this key pair or Jan 2018 on your machine, right? So I'll go, I did not delete it, I remember. So let's go there and say downloads, and it must be somewhere. This is star.pam. Yeah, it's right there, Jan 2008 PAM. So my file is there, right? It's just a certificate. Open that up. It has some garbage values. Looks like a certificate. It's a private key. It's right there with you. So I'm happy I don't have to worry about that. I'll check that and say launch instances. Okay. Click on this unique identifier, which is I hyphen some number, right? Now this one is created in US East 2A. Now my objective is to create in a different subnet. Remember this picture? My instance, this instance is ready now. I want to create a second instance in a second subnet, which is in a different availability zone, right? So while this machine is getting created, let's go build a second one. Launch instance, click on select. Okay, just ensure that you have T2 micro. Next, select your network. And this time I'll select the second one. Remember the first one was in 2A. This one's gonna go in 2B. Yes, I want to give it a public IP so that I can access it from the internet. Next. All right, happy values, good. Add tag, name, let's give it as web server 2. You can add more tags if you like. Next. Yeah, port number 22 is good. We'll add new rules later on because I want to make it a web server, so HTTP should be allowed. I'll say, look at all these values, launch, and I'll use the same key pair, launch instances. That's pretty good and pretty fast. So now I have two instances, which is server 1 and server 2, both of them in different availability zones, just like the way we discussed in this picture, right? Any questions so far?
No.
Okay, it's pretty straightforward. Okay. Now, what we have to do is understand how we log into these machines, right? How do we log into these machines? Because when I right click here, get Windows password is grayed out because it knows it's not a Windows machine, it's a Linux machine. There's nothing called get Linux password, right? Now we have to use a key pair here. The way we log into Linux machines is by using either SSH command, or if you just right click and say connect, it will tell you various ways in which you can connect to it. You can just use this command SSH. If you're using a Mac, then this is what will help you. But if you're using a Windows machine like this, like the way I'm using, so hey, let me just do a quick poll. Are you using Linux machine or Windows machine, or a Mac machine? Anybody using Mac to do the labs? Okay. So everybody's using Windows, it seems. If you're using a Mac, please let me know because the procedure will be a little bit different. So here you need to convert the PEM file that we downloaded. Remember, we downloaded this file, jan2018.pem. It needs to be converted to another file with an extension called ppk. Now, in next couple of minutes, I'm going to show you how do you convert PEM file to ppk using a small tool called as putty-gen. Now, where do we download that from? You need two files. Number one, putty to connect to non-Windows or Linux-based OS operating systems, and then you need putty-gen as well to convert the PEM file that you downloaded to ppk, right? Where do we download this from? Well, from the internet. We'll just go there and say download putty. So download putty. Now there'll be hundreds of websites who have putty software uploaded, this guy, that guy. I usually don't go to some random website. There's one website which I really like. I don't know why it's doing my Yahoo search. I like look. All right, say putty. All right, putty. Yeah, this one. CHIARK, right? This is no advertisements, no nonsense. It's just straightforward. Oh, okay. Did they change here? Yeah, this one. I'll put this in the chat. So that way you get the right link. Okay, it's right there in the chat. Now you have to download the first one, which is puri.exe, and the second last one, which is purigen.exe. And we don't have to download the 32-bit because I'm assuming that in today's world everybody is using 64-bit machines like i5s or i3s, right? We're all using 64-bit machines, so download this one, and also download purigen.exe for 64-bit. I'm not going to download because I already have it, so I'll say purigen and then launch it, right? Okay, that's how your purigen looks like. Okay, that's purigen. What do we do here? Now there's so many buttons, file, key, da 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 da. There's so many of these radio buttons here. Trust me, you do not have to click on anything. When you're going through the internet, you may see blogs, you may see videos which says, hey, click here, change this, do that, do this, etc. Don't do anything. There are only two buttons that you should be worried about in this entire screen. Those two buttons are load and save private key. That's it. These two buttons. You don't have to do anything. Don't click on generate. Don't click on any of these radio buttons. Click on load and load your PEM file. My PEM file will be in what was it? Jan. Yeah, that's my PEM file. And open. That's all. Done. And it shows up my entire key. Good. Now don't worry about any of these things. No radio buttons. Don't type anything here. Click on save private key because these are the only two buttons that we should be worried about. Save private key. All right, save it and just give it some name. I'll save it on my desktop and just give it some name like beautiful day. I don't have to give an extension because it's automatically saved as a PPK file. Save it. Done. Once you saved it, go ahead and ensure that it's in the place. Yeah, it's right there. Beautiful day.ppk. Once it is confirmed, just close it. Done. Now is the time that I can launch Putty. One. Good. All right. So what do I do now? Go back to my AWS to see what's going on. Okay. Looks like this server is ready. Both of these are ready. 2x2 checks are complete. Good. So let's log into them one by one. I'll take this public IP and then go to my Putty, paste it there, and then don't click on open yet because now you have to use the PPK file that you just generated with PuttyGen. To use it, click on SSH, auth, and then browse to that file. Where is my file? It's on my desktop, I believe. Beautiful day. All right, and open. There you go. If you get this pop-up, you should be happy. It's accepted your key, right? Yes. Now log in as. In Linux, we know just like Windows has administrator, Linux has root. But in this case, you'll be using ec2-user and hit enter. No password required because it's gonna import the keys, and now you're logged in, ready. You're ready, right? So all your Linux commands gonna work. PS, say EF, it's not gonna work, right? ls, pwd, where am I? Who am I? Who am I? Right? It's all gonna work. So it's all there. So it's a real machine. Log in. Let's try to make it a web server, right? How do you make it a web server? I'll just say install, right? Sudo yum install. I want to install the daemon called httpd daemon. Go ahead and install it. Well, yeah, are you sure you want to install it? Is this okay? Yes. Hit enter. All right, let's take a step back, relax, and it's done. It's a web server now. It's ready. So all you got to do is take this public IP, copy it, and put that in the browser. It's connecting. It's not working because you did not open port number 80 on the firewall or in the security group. How do you do that? Now look at one of these properties. One of them is called as security groups. If you click on view inbound rules, it's going to give you a preview, and it tells me that only port number 22 is open. From where? From everywhere, from the internet, right? And that's why you could get in. But port number 80 is not open. So you got to go and edit the security group. To edit it, click on Launch Wizard 3, and then inbound rules, edit, add, in the drop down, select HTTP, and make sure that you got 000 here and save it. Done? All right, I've got 2 instances. Now let's go back to, yeah, refresh this page again. Refresh. Why it's not working? It's not working because my HTTP daemon is not started. It's a sudo yum. No, it's not yum. Sudo service. It says started. When HTTPD started. All right. Now let's go ahead and check the status if it is really started. Right, this is running. Now refresh it. There you go. That's your first page. Right? Let's go and customize it again. It says you can now add the content to /var /www/html. You can go and add your content, and then you will have your customized page. Yeah, let's go and learn how to do that. I'll clear this. Right. Now I'm going to navigate to cd/var /www/html and enter. And I'm going to make a file called index.html. Remember, we did the same thing yesterday, right? In Windows, in C, inetpub www root folder, we created a file called as index.html, right? So I'm going to do the same thing in /var www.html folder. I'm going to create a file called touch index.html. Enter. Permission denied. So we know because it's got to run as an administrator. Sudo is the command. Done. So when I do ls, my index.html file is ready. I'm going to customize that file. Just put my custom content index.html, and then insert. Write something here, right? So just call it as this. This is server 1, right? One like the numeric 1. I'll put some exclamation just for fun, and then I'm gonna save it. Right and quit. Okay. Now if I do cat index.html, right? This is server 1. Now if I go back to the browser, hit refresh, right? There you go. Any questions so far? Your first web server is now ready. Now what I'm going to do is do the exact same thing for web server 2, right? Now, say right click, a new session, and I'm going to keep quiet and do these things quickly as you watch me do it, right? Just watch me. SSH auth browse to a beautiful day. Open. Yeah, okay, good. EC2-user. Okay, done. Install HTTP daemon. Done. Start the service. So sudo service HTTPD do what? Start with that. All right, now pick up this IP address. Right click and say go to. Anybody can tell me what is the problem? It's not working. The service is also started. What's the problem? Why is it not working? All right, I've got one answer there. Anybody else? Right, EBO is right, is the port number. So I'm going to go to my second server and then view inbound rules, port number 22. Well, that tells us it's really not open. And go to launch wizard 6, edit the inbound rule, edit add rule, and say HTTP. Okay, verify all of this and save it. And now, if If you refresh this, it must work, right? I'm gonna go and modify this again. Navigate to /var www html. Go there and then say sudo touch index.html. That file should be created. It's done. And now I'll say sudo vi index.html. Open that up and say this is, wait a minute, this is web server 2, like 2, right? And then put some exclamations just for fun. Save it, write and quit. Refresh. Done. So we got both the servers ready. This is server 2 and this is server 1, right? Now, any questions before we move on to load balancer section? Should we move on? Should we move on, guys? We good? Okay. So if you look at the picture here, we got web server 1 and web server 2. This is these are the two servers that are built, and what we have to do is go and create a load balancer, right? Let's go build the load balancer. And to create a load balancer, on the left side, you got to slowly scroll down till the point you see load balancer. Click on load balancers, and then you will see a button called create load balancer, right? Create. And you got 3 of these options. You got application load balancer, network load balancer, classic load balancer. There are multiple load balancers that Amazon is providing. I think till October last year, there are only 2 kinds of load balancer. One is application load balancer, and second one is classic load balancer. But since November, they introduced a new one called network load balancer, because the application load balancer could not handle bursts of or millions of requests per second. It could not handle that. So there's a sale period going on, and then there's tons of requests getting into your network. Application load balancer really used to hang. So that's why they got network load balancer, which can handle pretty busy networks. It can handle millions of requests in a second. If you want to maintain ultra low latencies, that's when you use NLBs, network load balancers. Application load balancer good for small and medium business companies doing HTTP and HTTPS traffic only, right? This one, classic load balancer, will be deprecated pretty soon, and it was used for all kinds of traffic, HTTP, HTTPS, and TCP. But now this has been split up. I say if you want to use HTTP and HTTP transactions, HTTP and HTTPS transactions, then you use application. Any kind of TCP traffic needs to get into NLB, right? In this case, I'm going to create an application load balancer. Say create, and give it some name. Let's say my ELB, right? Do you want this ELB to be internet facing or internal? Internal, we'll give it just a private IP and not a public IP. And because we are testing from the internet, we'll be using internet facing. Do you want this device? Do you want this load balancer as a device to get an IPv4 or IPv4 and IPv6? So if you select dual stack, you get both IPv4 and IPv6. What is the port number load balancer is listening on? 443 or port number 80? Well, you select the one that is meant for your business. In production, you will have HTTPS, but In this environment, you can just go for HTTP. Now, if you scroll down, it will show you the list of VPCs that we have. I'll select my VPC. And then within this VPC, I may have like 20 different subnets. But where are my web servers? My web servers are in this and this subnet, right? I'll select that and say next. What's the problem? Selected subnets must have the CIDR block required by the IP address type. This is because I selected dual stack here. I'll select IPv4, and then there should not be any problem. Good. Now this is just a warning. Don't worry about it. It's just a warning. Your load balancer is not using any secure listener. I'll go take a step back and explain that to you. Here we are saying that it's internet facing. That means our load balancer is internet facing. When it is internet facing, I need to use some kind of certificate to protect the confidentiality of information that's flowing from one point to another. So that is protected if you use HTTPS. Basically, Amazon is just warning us and telling that, hey, you are using internet facing load balancer and then using port number 80, which is not secure. It is only a warning and not an error message, right? And so next. Now you can choose a security group. This security group is for the load balancer, right? So you have one security group for the instance, one security group for second instance, and this third security group for load balancer. You can either choose first one, create a new security group, or this one, doesn't matter, right? I'll choose an existing security group, or maybe create a new security group and let port number 80 be there for inbound connections. So it's good. And say next. All right. Do you have any questions so far till step 3? It's pretty straightforward. Now, what is a target group? Target group is a group of servers. So if you look at the picture, you have server 1 and server 2, both of these. These two servers, which are behind the load balancer, will be in the target group, right? So I'll just give it some group name. And the group name is, say, bunch of servers. What is the port number it's listening on? What is the protocol it's listening on? So that's something that you define, because in this case, it's just a test environment. So I'll be happy with HTTP, or else you can select HTTPS if that's in production. Now, health checks is also important. Why? So if the server is in production, then the server will be rebooted at times, because the people like us who will be patching, rebooting the instances, etc., we're doing our work, we're doing our job to reboot the server after patching. It's good, it's good practice. But the load balancer must somehow know, hey, that server is actually down, so let me not send the traffic to that instance. So if you look at this picture, what if the server on the left side, which is web server 1, is rebooted by the application owner, and you do not want that load balancer to send the traffic to web server 2? If it sends, it will fail. So you tell the load balancer when to consider the server as healthy and when to consider the server as unhealthy. Well, this is where we define when not to send the traffic to the load balancer. Now I'm saying that if the server is not reachable on port number 80, which is HTTP, or is not reachable on HTTPS, right? It's not reachable on this protocol, then what do you want to do? You don't want to send the traffic, because the server is being rebooted, the server is being patched. Okay, Ibo. Yeah. So right after creating the security group, right here, we are in the routing section where we are creating a target group. A target group is a group of servers. So we just gave it some name, and then we are telling that when not to send the traffic to the server that is being maintained. So if the server is restarting, of course, the port number 80 will not be reachable. You don't want to send the traffic there, right? So here you're telling what is the healthy threshold, what is the unhealthy threshold, what is timeout interval, success code, etc. You define that. That means that the load balancer will poll the machines, will poll the instances behind the load balancer, and how many times it's going to poll before it considers healthy or unhealthy. A healthy 5, unhealthy 2. So load balancer, let me go back to the picture. Load balancer communicates with the web server, and if the web server is reachable, it says, yeah, the server is healthy. If the server is not reachable, then what will happen? If, let's say, the server is not reachable now, it's down. So how many times should the load balancer try before it consider it as unhealthy? So in this unhealthy threshold, the target group, which is a bunch of servers, will go and talk to so the load balancer will go and talk to the bunch of servers. And if it's not reachable, it doesn't send the traffic there. Simple. So the load balancer tries once, tries for the second time as well, and if the server is not reachable, it considers it as unhealthy. What should be the frequency between each poll? It says that the frequency interval must be 30 seconds. So it's going to keep on trying every 30 seconds. What should be the timeout value? The timeout value is if the server is not reachable in the first try, it doesn't want it to go into inside an indefinite loop, right? So I'll say if the server is not reachable in 2 seconds, then it's not reachable. Yeah, if it's not reachable for two times, unhealthy threshold 2 times, healthy threshold 5 times. So it's going to contact the web server or the Linux server 5 times before it considers it as unhealthy. Any questions on this one? So it's going to try 5 times, 1, 2, 3, 4, 5, and frequency between each of them is 30 seconds. It's going to try 2 times, 1 time not reachable, 2 time not reachable. All right, let's mark it as unhealthy because you said 2, and the frequency of each retry is 30 seconds. Next, you register the targets. Where should the traffic land up to? So if you scroll down, you'll see your instances, server 1 and server 2. Selected. Boom, my web servers are now ready. Yeah, let them listen on port number 80. Good. And make sure that you click on add to register. They should be visible right there. Okay. Now say next and then review it. Okay. Almost done. Closed. All right. So my load balancer is created. All right, looks like this load balancer has this DNS name called myelb whatever. I'm going to just copy and paste that in the browser. Say copy it, and then to paste it. Okay, it's still in provisioning status, and that's why it's not working. It should change from provisioning to active. It must change from provisioning to active. That's when it is 100% up and working. So I'm gonna just refresh it and keep refreshing till the point I see active. It takes a while, like a minute or two, nothing more than that. You have to just wait. Status is provisioning. And just refresh the page just for fun. Still provisioning. But behind this, who are the listeners? Behind this, I've got this bunch of servers as the listeners. Okay, refresh it again. Load balancer. Still provisioning. Any questions? Any questions on this one? All right, look at this. It is active now. It's active now. So now I'm going to go to my DNS name, copy this, and then just put that in the browser. Go to that link. Look at this. This is going to web server 2. That's good. Now I'm going to refresh on my page. Just say F5, F5, F5 a couple of times. Look at this. It's toggling between server 1 and server 2. Server 1, server 2. So hit refresh again. Just goes there. I'm just hitting refresh on the keyboard. So I think round robin works. Server 1, server 2, server 1, server 2, server 1, server 2. Good so far? Okay. With that we conclude the implementation of load balancer. How much time did it take? About 30 minutes to create a load balancer, right? Load balancer and then web server 1, web server 2, the entire lab activity took like 40 minutes, 45 minutes almost. Do you have any questions for me? So I'll stop this session now because the next lab is auto scaling and that takes more time. And then I would also like to go step by step instead of going through another topic in a hurry. I'll leave that topic for tomorrow. And while doing this lab, this particular lab of load balancing, if you got any questions, I can just email. So this one is like web server 1 and web server 2. Yeah, you got load balancer as well. So I'll go ahead and do this lab. Creating these two servers, Linux, because there's too many steps here. I don't want to confuse you by bombarding a whole lot of things here. So first step here is to create a Linux server, then convert that PEM file to PPK, login, and make it a web server. Okay. Then do the same activity for web server 2, then put ELB, and then put them behind the target groups. Yeah, that's all. And see if you can do round robin. The only reason I changed the default web page to server 1 and server 2, the only reason is when I hit F5, I will actually get to know where it is going. If you put the same content, you will never know where it is going. But if you put different content, you'll easily be able to gather information. Well, it's just round robin. If you have the same page and you do F5 100 times, it will appear as if it is picking up the same thing, because yeah, episode 1 and episode 2. So any questions? Will I do it? Should I leave it here? Okay, thank you. So that was a pretty quick session, but then the lab is still exhaustive. I'm saying exhaustive because you're new to it. So once you're done with the lab end to end, you'll be very comfortable with that, and it's then going to appear to be very small. Please go ahead and do that, and email me if you have any questions. Hey, thanks, Manny. Okay, then give back a couple of minutes back to your life, and we'll wrap up the session for today. Although we are leaving early, almost close to an hour class, leaving early, but then we can use that time to, um, yeah, we can use the time to do the labs. Thank you, guys. You have a good one. Please email me if you are stuck with the labs. I'll have the videos uploaded pretty soon. Today itself, I'll have that uploaded and send that Google Drive link to you as soon as it's done. Yeah. Thanks, Evo. Thanks, Evo. Yeah. Thank you. Thank you. So I'm signing off for the day, but I'm always on my email. Thank you. Bye bye.